That. Okay, so we're at the final session of the day. Thanks to everybody who's stuck it throughout the day. I hope you found it a really interesting day. The final session, we've got some really interesting talks coming up, including this first talk from Douglas Heggie, who is a local member of the Astronomical Society of Edinburgh. And we've been so lucky today to be able to use this venue and to have the support of the local society to set this meeting up. As director of the comet section, I can find the speakers and I can do all that kind of stuff, but all of the arrangements of the venue and getting everything done so that you guys can come here and experience these talks is all really down to ASE. So if I don't get a chance to thank them at the end, I'd really like to thank them now. And a round of applause, I think, for the Astronomical Society of Edinburgh and what they've done for us. So one of the really special things that ASE have done is that they have set up a remote telescope in Spain, and that's no small task. And to do it as a local astronomical society is a pretty amazing thing to do. And one of the things that they're using that telescope for is observing comets. And Douglas, I think, is the driving force behind that, possibly. Well, he'll tell us. Douglas, I think you said your first comet observation was in 1960, something like that. And you're a mathematician, so you're into the dynamics of comets. So all of this stuff, you know, Halley did this using Newtonian mechanics for Halley's comet. But comets are really interesting objects dynamically. So I guess that's kind of where part of your interest in comets comes. But Douglas is going to tell us about the comet work of ASE. Thank you, Douglas.
Well, thank you very much for the introduction, Nick. And I must say, as a local, it's been wonderful to see all these distinguished people from the BAA giving these fabulous talks over the morning and the first part of the afternoon. This is a rather more local contribution, as Nick said, on the comet work of the Astronomical Society of Edinburgh. He asked me in his introduction whether I was leading this effort, and I would say it's very much a shared sort of effort, and my partner in crime, as it were, is Mark Phillips, whom I particularly want to mention in connection with the organisation of this meeting as well. And Mark, unfortunately, is laid up at the moment, and he's deeply sorry not to be here in person, and I'm sure you'll be the first person to open up a recording of this session when it reaches him. But covering the comet work of the ASE, I also have this subtitle, Comets, ASE, Azero, and Me, with a possible appendix on meteors, which I may not have to cover, since it was already mentioned by Neil, the president, at the beginning. So I'll get rid of the me first of all, and I'll start with a Shanklin-like diagram of my recorded comet observations since my first one in 1960, when I was a schoolboy, and that activity continued. This is number of comets, sorry. This is number of comets per year. From 1960 until the present. And once I stopped being a postdoc and got a proper job, as they say, my attention to these things formally became much weaker. I mean, I was observing special objects like these two, whose names you'll be familiar with, and one or two others which I didn't record formally. But really, I'd left the thing in the doldrums for best part of 50 years, until COVID, in fact. And then my attention was drawn to ASE, with which I've had a connection for decades. And what attracted me to ASE and resuming activity in this kind of astronomy was the planetary imaging of Mark Phillips and others in the society, which I thought was astonishing from the background of planetary observation, which I had known as a schoolboy 50 years ago. And it turned out to be the same with comets. But I started avidly reading the ASE WhatsApp group in April 2021, and I noticed after 6 months that I hadn't seen a single comet post. And so I set about to try and put that right. I bought myself a small telescope, 5-inch, put it in my back garden, which is a bit light polluted. It's in a suburb of Edinburgh, and started trying to bomb the WhatsApp group with comet images, no matter how faint the comet. And then Mark noticed this after a few months, and he suggested to me that we should try and draw this stuff away from the main WhatsApp group, where it gets mixed up with all sorts of astronomical and non-astronomical points of contention. And he decided that we should try and form the Comet group, which was done in the spring of 2023, just 2.5 years ago. And I'll be talking about the work of the Comet group in this talk. And then the next thing that happened was First Light and ASERO, the Astronomical Society of Edinburgh Remote Observatory in Trevinca, which will be the topic of my next slide. Then the next major event was 100 years since the birth of the Astronomical Society of Edinburgh. We had a very nice bash in October 2024, organised by Mark when he was president, and the committee. And it's a singular success of an amateur organisation to be able to celebrate 100 years. And then, of course, the next major event was the occurrence of this meeting, which is again unprecedented in the ASE annals, and it's where we are right now. Now, let me try and work this and go on to the next slide, which is about the Astronomical Society of Edinburgh Remote Observatory. And it came into first light in July 2023 with just one telescope. We very quickly had our second one in operation. It's located at Trevinca, northwest Spain, and there's a map showing a drop pin where it is, just off the northeast corner of Portugal, in fact. The elevation is 1,250 meters, so if this was Scotland, this would be a record-breaking Munro. But I must say, this doesn't look anything like a Munro. It's rather more like the North York Moors, if you see a picture of the Trevinca observatory site. As astronomers, we'd be particularly interested in the weather. The weather is a wee bit like the location, some way between the Mediterranean and the Atlantic, in other words, and possibly a bit more Atlantic than Mediterranean, but definitely much better than Edinburgh. And it has other advantages as well, which I'll come to. And then it was this 94mm apochromat, which was the first telescope we used. I remember the director of ASERO, Ian Smith, saying that it wouldn't be much use for comets because it has such a small scale, or a wide field rather. But in fact, we made very good use of it on things like 12p for some months before the next telescope came online, which was this 12-inch Newtonian, which is now our workhorse for comets large and small. And then there's another one which is about to join this group once it gets set up by the team at Trevinca, which is really for planetary work. It's a much longer focal length, and it might even be particularly helpful for astrometric work on comets. So the organization of ASERO is that it's run by a small team of about 3 particularly active individuals. The director is Ian Smith, one of these, Mark is another one, and David Brett, who's here tonight, is one who's stood in to the ASERO team. Well, Ian Smith is away on a world tour, and Mark is, as I say, laid up. So it's great that David, who actually also has a telescope at Trevinca, could step into the breach. It works in the sense that, for everybody, in the sense that any ASE member can propose a target, The observations are scheduled, as you might expect, in the evening to work throughout the night, and it usually works very well. It covers all interests in the society, and somehow or other there's a red dot which should appear, but I've probably overused it. Anyway, you can read it as well as I can. The Comet group gets up to 3 targets per night, each target taking about half an hour. And its advantage for us, of course, is that it's at a lower latitude by about 14 degrees in Edinburgh, so that when Edinburgh is beset by no astronomical night, Travinca has several hours of astronomical night, and that's particularly good for doing things like comets. And in particular for a comet like 29P, which is more or less sliding along the ecliptic, that lower latitude just helps a little bit in keeping it elevated when it's just emerged from superior conjunction, or just about to go into superior conjunction. And it might not seem like a record by comparison to somebody like Denis Brzezinski, but we've managed around about 350 comet observations since first light, just over 2 years ago. And you can read about ASE on that web page. Now, the main output of the Comet group is housed on the members-only website, which is an issue which I've gradually become to regret while I've been writing this talk. Basically, the Comet group's web pages for ASE members only consists of an image and data gallery, of which this is a typical single entry. This one comes from Robert Arnold, who observes up in sky. So not all of these observations are made by ASE, but an increasing proportion are. And he gives the usual data for this observation. It's a particularly fine image, I think, of 12P. And usually there's data on the magnitude, yes, here it is, and on the size of the coma. And we would usually have measurements of the position angle and length of the tails if the comet does have them. I guess Robert couldn't really make up his mind which of the rays here coming off was the tail he should try and measure. So any ASE member who observes a comet can post, and there are about 200 members of the Astronomical Society of Edinburgh, but in fact the number of contributors is severely limited to these 6 or 7 people, and in fact almost all of the posts come from the first 3 people on that list of contributors at the bottom of the page. The way things are organized, well, there you have a note of how many posts we've had up to the time I was preparing this slide at the end of August, at 620 posts, and over half of these actually come from ASE. And we try and organize, or at least we used to try and organize this in terms of featured comets. 12P, 13P, 29P are obvious targets. 2023, A3, E1, K1, 3I, and A6 are featuring more at the present time. And yeah, this idea of featured comets and sub-projects is something which will probably get revised fairly soon. But it does help to do the scheduling night after night if you have a limited number of comet targets. One might think one would like to change the comet target night after night after night, but I think it would be hell for the people who are constructing the schedule for each evening. So as well as these posts of images and data, we also have spreadsheets of data on individual objects. But I must say, we don't make too much use of that, except on the odd occasion. Now, all of that, as I say, is behind the membership paywall of the Astronomical Society of Edinburgh. So what's the point of doing it, you might think? Apart from getting people to pay subscriptions, but I don't think it would necessarily. But there's a lot of public output of the Comet group. The one which has been the workhorse for us has been contributing COBS, the Comet Observations Database. And something terrible has happened to the slide here. It receives almost all of the data which accompanies these images, including magnitudes, coma diameter, and tail data. And that bullet point here, the second one, contributed more than 50%. This is just an illustration of the fact that actually the ASE telescope is particularly good for something like 29p, because in 2025, June this year, 29p was sliding into the superior conjunction, and in that part of its apparition, ASE was actually contributing over half of the world's observations as judged by the contributions to COBS, benefiting from the lower latitude and the better access for a comet near the sun. Of the software that we use for this data gathering, we used to use ASTAP almost universally, the astronomical stacking program, I think it means. We've switched to Tycho Tracker, and that's become almost universal as well, in turn, just in the last few months. And I'll mention the reason for these changes in just a minute. And there's one member of the Comet group who doesn't contribute much to the posts, Horst Maradix, who I think uses Comfort all the time. Okay, so that's the work of the ASE Comet group as it has been in the first more or less 2 years of its existence. And I want to say something about how one can raise our game. Now, I haven't mentioned one very active Comet member of the Astronomical Society of Edinburgh, and that's Dennis. And everybody here will know Dennis much more than anybody else, because he definitely works at a different level from almost everybody else. But he's been very good in providing me and Mark with helpful hints about what we could do differently or better, comets that we've neglected and will become interesting to observe in the next few weeks or months and so on. And I'm very grateful indeed to Dennis for the exchanges we've had over these 2 years. He may be disappointed in what has become of his suggestions, and I'll try and cover them in as much detail as I have time for in the next wee minute. So one of the things which he said long ago was imaging. Instead of keeping your posted images inside your membership paywall, why don't you send them to the BATA Comet Image Archive, which I often use myself for finding what comets look like. And he gave us the address, and I'm ashamed to say it was really only at the beginning of this year that I first tried it, and I wasn't encouraged by the results for some reason. And I didn't try it again until just about a month or two ago when I was writing this talk, and I realized, why the hell don't we actually take Dennis's advice and routinely send our images to this tremendous archive? And personally, that's what I've been doing with my data work from ASE in the last month or two, but it needs to be made part of our culture, I think, more widely. The next thing which Dennis suggested we might do is astrometry, as I've not mentioned astrometry before, but there were several reasons why we wanted to do it besides Dennis's recommendation, and that was the appearance of 3I, which in the very early days definitely needed some astrometry done in it, and we continued doing that systematically for some time until 3I really disappeared down into the twilight at A0. Again, it needs to be made routine. So I'm now sending all of my data, or at least appropriate reductions of it, to the Minor Planet Center, and this needs to be made widespread. Then Dennis also suggested looking at PCCP objects. I must admit I had no idea what PCCP objects were until vigorous web search. Even the MPC is not particularly helpful in finding what PCCP means. But it means possible comet confirmation page or pages. And I had a look at that actually, and I found that the limiting magnitude of A0, which we were getting on 20-minute sessions, was really not quite up to the tasks which seems to be required on the PCCP objects. So we haven't done anything on that, and I'll have to look on this screen here to see what the next thing is. Deep imaging of such and such an object. I can't remember what it was. Again, I decided that the images we were getting from the Merle telescope at A0 were really not deep enough to be better than what I could see on the Comet archive of the BAA, and so we didn't do very much about that. I hope I haven't missed out a whole category by truncating the page. Anyway, on the right there is the kind of comet image which I routinely send now to the BAA comet section, thanks to a little bit of correction and feedback from Dennis and Nick. And this is Tycho Tracker, which provides more or less all of the information you need on the annotations which it routinely produces, which makes life particularly simple. Plus there's a little logo for A0, which Mark designed when we got started. Now, that's more or less my complete description of the work of the ASE Comet group, and I'm more or less on time, I think, at this point, which is a good bit of luck. But I do want to have one slide, if I may. As Nick mentioned, I mean, I had a professional life as a professional theoretical astronomer on dynamical astronomy, and I must admit, I still can't get out of my head when I'm staring at an image of a comet, what does this all mean? Dennis's attitude was, well, I think, well, this is paraphrasing it very crudely, well, we collect all the data, send it to COBS and places like that, and let the professionals deal with its interpretation. Why should the professionals have all the fun? That's my point, actually. I think as well as observing things, we should understand them. And I could get an egg in my face for this slide, but let's just press ahead. I remember in the spring being very struck by images of 29P, which for week after week always seemed to have a faint extension to the northeast. And then a couple of months later, it seemed to have a faint extension to the northwest. So, I'm sorry, it was the other way around. It was around about Christmas time last year. It was the northwest, and then it moved into the northeast. Now, I've seen these faint extensions described as what happens to the outbursts when they've expanded by a large multiple of the diameter. But I started measuring up all our images and trying to measure the position angle of the faint extension. And I found a fairly systematic trend, with one or two exceptions, which can easily occur when the thing is very nearly circular. And I wondered what it is that we're actually looking at here, or rather what it definitely comes from the outbursts, but what is it that drives it in that particular direction? Is it the direction of the outburst, or what usually drives the orientation of comet tails, which is the radiation pressure, the gravitation, and the motion of birth in the comet? And so how could one understand, for example, oops, oh God, there we go. How could one understand, for example, the movement from northwest to northeast? And let's just suppose there was a tail of 29p, which was directed away from the sun. And remember, we are observing it from well inside the orbit of 29p on a very small orbit, about 1/5 of the size. And before opposition, when you're at the upper part of the Earth's orbit, you can see round the right-hand side of 29p, as it were, to where this mythical tail is. And then after opposition, you observe the left-hand side of 29p is where the tail is. And so you would have a natural progression from, from the west to the east, which is more or less what was being observed. So I guess this goes back to a question which I asked myself a long time ago about 29p, which is, does it have a tail? Maybe somebody here knows, in which case I really do have egg on my face. But you can re-express the question as, what is it that determines the orientation of the outer coma of 29p? Is it the outbursts, or is it the forces which drive tails and other comets? And I'm very much looking forward to the next apparition, which has just started, as we've heard, to see if the same pattern of movement of the position angle from negative to positive, that is from west to east, persists in the next year. And that is my last slide. I did have one on meteors, but that was covered to some extent by Neil in the introduction, and so I'll just stop there.
Thank you, Douglas, and I think that actually sounds very plausible to me. One of those things, though, that observation is important because we can actually try and decouple the effect of the outbursts on the shape of that coma from your theory that it's maybe a tail. I mean, I assume it's a comet. It must have an ion tail, and the ion tail will be pointing away from the sun. So, okay, so I think we've got time for one or two questions before we move to the next speaker. So, Michael, you would be over there, wouldn't you?
Thanks, Nick. Great talk. Thanks very much. You referred to in one of your earlier slides about using ASTAP for your plate solving, and you've moved away from that. Would you mind just commenting on that a little bit, please?
Yes, I think we moved away from ASTAP for, let's see, why did we move away from ASTAP? I think, well, it's a wee bit complicated. When I was using ASTAP, I was actually starting the stacking in Cyril. And then I moved to ASTAP to get the photometric calibration and the magnitude estimates and so on. And while I subsequently realized that that could all be done inside ASTAP itself, I realized also that there were advantages in using Tycho because it would deal with the astrometric measurements, which we were also starting to do. Furthermore, there was a lot of experience of Tycho in the society with Pat Devine, who runs the asteroid observations. Yeah, it seemed a good choice, actually. The other issue which you have to choose about is Astrometrica, where we have very different attitudes to just using it. It's hard to use, I find. I give myself the extra barrier of trying to do this on a Linux machine under Wine, and it only just works, but it's very painful. Even Mark, who uses a Windows machine, I guess, finds Astrometrica involves a fair amount of head banging. I don't think that's what's made a mill, but anyway, there we are.
Yeah, I think we have very different opinions on that. Dennis and I have used Astrometrica forever, and we kind of managed to get it to work, but I know it can be difficult. Okay, we better move on.